Okay, here's problem number 3 from the North Carolina Math 1 EOC from 2016. And this problem is very straightforward as compared to a lot of the other problems on the Math 1 EOC, simply because it's just straight algebra to do. There's no setting up of the problem. There's really not much in the way of interpreting the problem that you have to do. It's just a matter of figuring out which of these answer choices, which of these algebraic expressions is equivalent to the given algebraic expression. And as it turns out, there's at least 2 ways to go about solving this problem. One, if you recognize that this is a quadratic expression and you know how to factor this quadratic expression, well then you can factor it and then choose the correct answer choice from your factors. If you don't know how to factor it, if you can't figure out how to factor that expression, or if you don't recognize it as being a factorable expression, you could work backwards. That is, you could take each of these answer choices and you could just multiply the 2 binomial expressions together for each one until you find one that gives you t squared minus 36. So let's do this both ways. So first off, this is a quadratic expression, and that might be a little confusing to some people who look at this, because they might think, well, that can't be a quadratic expression because there's no middle term. Quadratic expressions are supposed to look like ax squared plus bx plus c, and this expression, it doesn't have an x term in the middle. It's just got the square term and the constant term. And that's true, although one way to look at that is that, well, it does have an x term, it's just that it has an x term with a coefficient of 0. So if the value of b is 0, then you get ax squared, no middle term, plus c. And that's what you have here. Another thing about this particular quadratic expression that some of you may have recognized is that this is a special kind of quadratic expression called the difference of 2 squares. T squared is a perfect square expression, and 36 is also a perfect square expression, and since 36 is being subtracted from t squared, it's the difference of 2 perfect squares. And anytime you have the difference of 2 squares, ax squared minus c, it always factors the same way. It factors into the square root of the first perfect square, and the square root of t squared is t, so that's going to be your first term in each of the 2 binomials. And then the square root of the second term, and the square root of 36 is 6. And since it's the difference of 2 squares, one of those is going to be positive and one of them is going to be negative. And I can see right away, well, this matches t plus 6 times t minus 6, so B is my answer. If I didn't know how to factor the difference of 2 squares, I could just go through each one of these and multiply each one of them together using FOIL or the distributive property or the box method. And only one of them is going to match t squared minus 36. And let's go ahead and try that out. If I do t plus 6 times t minus 6, if I just multiply these out, t times t is t squared. T times negative 6 is negative 6t. Positive 6 times t is positive 6t. And then my last terms, positive 6 times negative 6 is negative 36. And you can see what happens to the t term. Negative 6t and positive 6t, those 2 terms go away, since negative 6t and positive 6t is 0. So that leaves me with t squared minus 36. Notice if you try to do the same thing with, for example, answer choice A, t minus 6 times t minus 6, that would give me t squared minus 6t minus 6t, and then negative 6 times negative 6 is positive 36. And when I collect up these 2 like terms, negative 6t and negative 6t gives me negative 12t, which does not match t squared minus 36.